Okay, very welcome back once again. So as you can see in this module, we will talk about two important concepts in physics and in electronics, that is a resistance and a conductance. These two are the electrical quantities. Resistance means is the quantity that opposes the flow of electric current in a circuit, and its unit is expressed in ohm. On the other hand, the conductance is the quantity that allows the flow of an electric current. So you can see that these two are reciprocal to each other. And the unit of the conductance is Siemens S, or in earlier, it is also expressed just opposite to ohm, it is also expressed with this unit called as mho. So the formula for the resistance, as we have seen in our previous model, R can be expressed as voltage divided by current, and the conductance is expressed as G, which is the reciprocal of resistance. Therefore, it can be I over V. So resistance is V over I, and the conductance is I over V. And also we can write G equals to 1 over R, or we can also write R equals to 1 over G. So this is how this resistance is. So here we see that there is an example where resistances are connected in series, starting for R1, R2 up to Rn. And analytically, we can express that connection with this equation. R equals to sum of all the resistances, where Ri stands for I equal to 1 up to n. So the resistance R1 is from R1 to Rn. Okay, so here we can see that resistances are connected in series, and mathematically we can write this in this form: R equals to sum of all the resistances Ri, where I is equal to 1 and it is up to equal to n. And that is then equal to R1 plus R2 plus R3 up to Rn. So there are n number of resistors. Obviously, the conductances in series can be represented by this equation right here, where we see that G, which is the reciprocal of resistance, is equal to sum of the reciprocal of, no, I think I have messed it up. Okay, so here we see that the resistances are shown to be in series. There are up to n number of resistances starting from R1, R2, and Rn. And analytically, we can write that R equals to sum of resistances Ri, where I is equal to 1 up to I is equal to n. So there are n number of resistances. That is then equal to R1 plus R2 plus R3 up to Rn. So there are n number of resistances. Conductances in the series can be expressed by means of this equation, where G is the conductance, which is equal to reciprocal of, because there is a -1 sign, reciprocal of, in bracket, sum of the reciprocal of all the conductances Gi, where I varies from 1 up to n. And that is finally solved as the reciprocal of, again, the reciprocal of all conductances 1 over G1 plus 1 over G2 plus 1 over G3 up to 1 over Gn. So remember, so with this formula in mind, let us say you have two elements of the conductances in series, and how they would be expressed, which is shown right here figure. G equals to G1 G2 divided by G1 plus G2.